We're going to be looking at the integral of x e x squared dx. Now, whenever we take the integral, we're always going to look at the problem part and decide what we want to do because there's several different integration methods. So for the problem part here is this ex squared, more specifically this x squared right here. So what we can do is use substitution. Notice that if we set u equal to our x squared and we take the derivative of it, we get du is equal to 2x dx. And this looks very similar to what we have here. So if we rewrite this, we'll have du over 2 is equal to x d of x. And this x d of x right here is this dx and this x. So we can go about replacing this. We're going to have the integral. We're going to have our replacement, which is du over 2. And then we have our eu, because this u is subbed out for this x squared. We'll have to sub it back in later, but that's okay for now. So we have this e to the u, and if we rewrite this so that it's a little bit cleaner, something we've looked at more commonly, we're going to have eu. We can move the constant out front. We'll have this 1/2, and then we have our du right here. And whenever we take the integral of this eu, or e to anything, it's just going to be itself. So if we write this out, we are going to get a eu over 2, and we want to plug in for our u, so we're going to get ex squared divided by 2. And that's going to be our answer for this. If we wanted to go and check this, what we would do is say, let's derive this. So deriving this, we're going to just have our constant out here. We have our ex squared. If we derive it, it's just going to be itself, so we have this ex squared. Then because of chain rule, we have to take a look at this top part, and then we're just going to have this 2x. We can see that the 2's are going to cancel out, and we're just going to have an x times e to the x squared. So that checks out. That's how you would check our work, and that's how we would get our answer. I did make a mistake though. It doesn't look very noticeable on the surface, but since we don't have any limits here or here, we don't have an upper limit or a lower limit, we're always going to need a plus c. And this is whenever we don't have limits. So always add this plus c. It stands for a constant. We don't need to go too much in detail about it, but that is for whenever we integrate and don't have limits.